Recall that in the previous video we stopped over here where we wanted to find out these probabilities over here to compute these extra two cells. So let's see, what are we computing here? The probability of recommending a movie and being bad. Recommending and being bad. Now, what's that going to be? We're going to use conditional probabilities again. So that's the probability of recommending a movie given that it is bad. So the probability of recommending given that it is bad multiplied with the probability of having a bad movie. Now, what's that going to be? The probability of recommending given that it is bad. We found it in the previous video by using complement probabilities, and we found it out to be 0.25. So that's going to be 1 over 4, in other words. So 0.25. Let's just write 0.25 first so that we know what it is, and then we'll convert into fractions so that it's more extensive. And the probability of a bad movie, again, we know it from the question, the probability of a bad movie is 0.75. So that's 0.75. Now let's convert this into fractions. What's that going to be? We will have 1 over 4, 0.25, times 3 over 4, which is 0.75, and that gives us 3 over 16. So that gives us 3 over 16. Let's write it over here. This cell is 3 over 16. And the probability of recommending a movie, so overall, this probability of recommending of a movie is going to be equal to 3 over 16 plus 3 over 16, and that gives us 6 divided by 16. And if we cancel out by 2, if we simplify the fraction by 2, that's going to be equal to 3 over 8. 3 over 8. Now, let's see what's going to be the other probability on the other cell. We're looking for the probability of not recommending and having a good movie. So, not recommending and having a good movie. Let's write it like that. Not recommending and having a good movie. Now, that's going to be the conditional probability of not recommending given that it's good. Probability of not recommending given that it's good, multiplied with the probability of having a good movie. The probability of having a good movie. Now, what's that going to be? Again, from the previous video, by using complement probabilities, we saw that the probability of not recommending a movie given that it is good is 0.25. So we write it over here below. That would be 0.25. So 0.25 multiplied with the probability of having a good movie. The probability of having a good movie. And again, given from the question, that's equal to 0.25. So let's write it like that. 0.25. 0.25. Now what's that going to be? That's equal to 1 over 4. So that's equal to 1 over 4 multiplied with 1 over 4. That gives us 1 over 16. So it gives us 1 over 16. Let's fill this in. That's 1 over 16. Let's add the probabilities for the not recommended cell over here to calculate what's the total probability of not recommending a movie. That's 1 over 16 plus 9 over 16. That's equal to 10 over 16. And if we simplify this fraction by 2, that's equal to 5 over 8. So that's 5 over 8. 5 over 8. Now 3 over 8 plus 5 over 8 gives us 8 over 8, which is indeed the total probability. So this is equal to 1 in total. That works out very smoothly. Now we have these probabilities. We'll also use some other conditional probabilities along the way, but to make it more of a flow, so not solve all the probabilities first and then the question. Let's go to the question to see what probabilities we can use at the moment, and then we will complement with the probabilities that we still need. So first of all, when solving a decision tree, we know that we go to the end of the question and see that how to go backwards. So we can see what is the payoff that we expect and go back to see what are the probabilities that we expect. Now, over here, what do we have? We have the payoff of having a good movie given that we ask for an advice. And we know that the advice costs us 8 euros. And the happiness from seeing a good movie is 64 euros to us. So, once again. The happiness of seeing a good movie is 80 euros. We pay 16 euros for the ticket, so that gives us a payoff of 64. But then we pay 8 euros for the advice because we're thinking about the scenario where we ask for the advice to go for a good movie. So that's going to be 64 minus 8, and that's equal to a payoff of 56. That's one cell. What would happen if we saw a bad movie and we also asked for advice? Well, we already have a loss of 16 euros for paying for the ticket, and then also 8 euro loss for paying for the advice. So we have an overall payoff of minus 24. Hope this makes sense. Now let's go here below. if we do not go to the movie overall, if we do not go to the movie, we don't pay for the movie, but we pay for the advice still, because that's also the scenario when we ask for the advice. So the payoff over here would be equal to just -8, the cost of the advice. Now, what do we have here? We have the payoff of seeing a good movie. Okay, so it's gonna be the same scenario. 64 euros of happiness minus the 8 euros of paying for the advice, so that's 56 as a payoff. The probability of having a bad movie would be the -16 cost of the ticket minus 8, which is the cost of the advice, so it's a -24 payoff. And if we do not go to the movie, but we still ask for the advice, we only pay the cost of the advice, which is 8 euros, so -8. Now over here in the last part, what do we have differently? We have the scenario where we do not ask for advice. So the payoff is just going to be the difference between the 80 euros of happiness and the 16 euros of cost, so that's 64 payoff for the good advice. Over here, if we have a bad movie, our happiness would be just -16. So -16 because we paid for the ticket, but we did not get any happiness out of it. And for the last case, if we do not go to the movie and we also don't ask for any advice, we spend no money, so the payoff would be 0. Now with this in mind, we will start going backwards. We will start calculating the probabilities, and since we're working on decision tree, we will have conditional probabilities. For instance, what kind of probability do we have here? This is the probability of having a good movie given that it is recommended. So if the advice, let's read it in common sense, in common English. If the advice is to go, meaning that if it is recommended as a movie, what is the probability that it is good? So we're looking for the probability of having a good movie given that it is recommended. And over here, we're looking for the probability that it is a bad movie given that is recommended. So we have to calculate these probabilities. And we'll calculate these probabilities in the next video.